Hello students, today we deal with the complex matrices, conjugate of a complex matrix, conjugate transpose of the complex matrix, Hermitian matrix, skew Hermitian matrix, and the unitary matrix. These are very important topic. Okay, so very simple definitions and the simple explanations are there. Okay, just we start with a complex matrix. Very easy. Okay. We have studied the number of matrices in the previous classes. If all the elements or all the entries of a matrix are real number, then it is said to be a real matrix or a matrix over the set of real number. It is quite easy to write na or to understand what do you mean by the real matrix. A matrix, if all the entries are 0, then it is the real matrix, or a matrix which entries belongs to the set of real number, that is a real matrix. On the other hand, if at least one element of a matrix is a complex number, and complex number, we represent it in the form a plus iota b, iota, it is the iota, okay, where a and b are the real number and iota is equals to square root of -1. Then the matrix is said to be the complex matrix. Very easy to write or to understand, to remember that a matrix, if at least one entry uh, uh, exists in the given matrix as a complex number, then this matrix is said to be the complex matrix. Or all the entries may be the complex number, at least one entry. So what do you mean by the conjugate of a complex matrix? Whenever we talk about the complex numbers, then a conjugate words automatically occurs there. वो खुद ही चला आता है भाई, कॉम्प्लेक्स नंबर है तो देर विल बी कॉन्जुगेट ऑफ दैट कॉम्प्लेक्स नंबर. एंड हाउ डू वी ऑब्टेन द conjugate of a complex number? Just we simply replace iota part by minus iota in the given number, then it will be the complex conjugate. For example, if we have a complex number a plus iota b, then its conjugate denoted by the bar will be a minus iota b. That is, plus iota is replaced by minus iota, and you guys are very well aware about these small manipulations or small discussion of the complex number. So conjugate of a matrix, the matrix obtained by replacing the elements of a complex number a by corresponding conjugate by the complex number, then it's called the conjugate of the matrix A, and it is denoted by this. If that, it means if all the complex number are replaced by, it means that all the iota part in all the complex number in a matrix as written by minus iota, then the resultant matrix is the conjugate of a matrix. Conjugate transpose of a matrix. Transpose, conjugate transpose. So it is easy to see that conjugate of a transpose, conjugate of the transpose. So first transpose of the matrix is denoted by ADX, then take it conjugate. And transpose of the conjugate, that is the first take the transpose of the matrix, then take it conjugate. Then first take the conjugate of the matrix, then take it transpose, are equal. Conjugate of the transpose or transpose of the conjugate matrix are equal. Each of them is denoted by a to the power theta, means transpose conjugate is equals to conjugate transpose equals to a to the power theta. Okay, so these are the very simple explanations. Now we talk about the Hermitian and skew Hermitian matrix. Hermitian matrix. So first we talk about the Hermitian matrix. A square matrix capital A is said to be Hermitian. A square matrix capital A is said to be Hermitian is said to be Hermitian if conjugate transpose or transpose conjugate, that is a to the power theta is equals to the matrix itself. It means that is if we represent a square matrix A equals to Aij form, right, then Aij conjugate should be equals to Aij, right, Aij for all I comma j, right. Okay, so now by this definition we can observe the one point not, and what is to be noted here, that is Aij equals to this. Now for I is equals to j, what does it mean? It means Aii bar is equals to Aii, right. Aii bar is equals to Aii. Okay, what does it mean? It possible only if and only if that is Aii is purely real, is purely real, means all the diagonal element of a Hermitian matrix are purely real, means all the diagonal elements in a Hermitian matrix are real, right, in a Hermitian matrix are real. Or you can see by the another, for example, if we have the complex entry in, because on the diagonal we have the elements complex number is, and its transpose means a plus iota b, right. So what does it mean? A minus iota b is equals to a plus iota b, right. So the a is cancel out, and here we have 2 iota b is equals to 0. So iota from here, iota cannot be 0. Okay, since this implies that, or 2 iota cannot be 0, this implies b is equals to 0. So in the given complex number a plus iota b, b is always 0 by this definition in case of Hermitian matrix. So if b is the 0 on the diagonal, here we are talking about for the diagonal only, for aii, for I equals to j only. Okay, so in the case of the Hermitian matrix, the diagonal will be purely real, because a plus iota b will be a, because the b will be 0 in this case always. Okay, so it is easy to identify that the diagonal elements of a Hermitian matrix are always purely real. Okay, second thing, now we talk about the skew Hermitian matrix. Skew Hermitian matrix. A square matrix capital A is said to be skew Hermitian matrix if a theta is equals to minus a, that is if capital A represented by the Aij, okay, then Aij conjugate will be equals to minus Aij for all I and j, right. And one point to be noted here also, for I equals to j, we are on the diagonal. Okay, for I equals to j, we are on the diagonal. The entries a I bar will be equals to a I minus a I, right? Minus a I. That is, if we have the complex number a plus iota b form on the diagonal, then minus a plus iota b, it will be equals to this. Then a minus iota b, by the property of the conjugate, a minus iota b is equals to minus a minus iota b. So minus iota b is cancelled from both the sides, so it will be 2a is equals to 0, and this implies that a is equals to 0. So one point to be noted here very carefully, the elements on the diagonal of a skew Hermitian matrix are purely imaginary. The elements on the diagonal on Hermitian matrix not Hermitian, skew Hermitian matrix. Skew Hermitian matrix are purely imaginary. Purely imaginary. The real part will be 0. Purely imaginary, right? That is, the real part will be 0 in case of skew Hermitian matrix. Here we are going to give in some examples like Hermitian and the skew Hermitian matrices. Now, for example, the given matrix A, I am writing here 5, 2 plus iota, minus 3 iota, and 2 minus iota, minus 3, 1 minus iota, 3 iota, 1 plus iota, 0. Okay. Now, if we see here, it is the given matrix A. So, now we try to find out A theta. A theta is what? A theta, that means conjugate transpose. Conjugate transpose. That is what? First we take conjugate of all these entries. So 5, 2 minus iota plus 3 iota, then 2 plus iota and minus 3, 1 plus iota, minus 3 iota, 1 minus iota, and 0. It is the conjugate of the given matrix. Now we take the transpose of this. Then this implies that A theta is equals to, now first row will be converted into the column 5, 2 minus iota and 3 iota, then 2 plus iota minus 3, the second row, now 1 plus iota, and the third row will be minus 3 iota, 1 minus iota, and 0. Now come on, verify it, check it now. 5, 2 plus iota this, and which is equals to capital A. So it is a Hermitian matrix. This implies that the given matrix is Hermitian matrix. Right? It is an Hermitian matrix. First class. And see one more thing on the diagonal. The entries on the diagonal are purely real. The entries on the diagonal are purely real, as we have proved in the previous page. Okay, on the previous page, that the entries on the diagonal will be purely real in case of Hermitian matrix. Now here we recall another example of the, in case of skew Hermitian matrix. So we can take example of skew Hermitian matrix here, like the given matrix A is equals to 3 iota, 1 plus iota, then 7, and minus 1 plus iota, 0 minus 2 minus iota, then minus 7, right, and 2 minus iota, and it is minus iota, right, minus iota. So guys, here we need to check transpose conjugate of it, right? So that is transpose or conjugate transpose, transpose conjugate, both are the same thing. So first we take conjugate of it. So it will be minus 3 iota, 1 minus iota, 7, and minus 1 minus iota, and 0 minus 2 plus iota, then minus 7, and then 2 plus iota, and then plus iota. It is the conjugate of the given matrix. Now we can take it the transpose of this. Now this implies that a theta is equals to the first two convert into the first column, 3 iota, 1 minus iota, then 7, and minus 1 minus iota, then 0, then minus 2 plus iota, then 2 plus, sorry, it is minus 7, right? It is minus 7 here, then 2 plus iota, and then iota, plus iota. Okay, now multiply by take the minus outside from this matrix, so it will be 3 iota, 1 plus iota, and then 7, right, and then minus 1 plus iota, then 0, then minus 2 plus iota. Okay, let me check, here we have done some mistakes. If I am writing here 2 plus iota, right, okay, it will be minus 2 minus iota. Let me write this. Okay, let me write this. Come on, once again, 3 iota, 1 plus iota, plus 7, minus 1 0, then it is minus 2 minus iota, then it is minus 7, then this is 2 minus iota, and then minus iota. Now confirm the given matrix with the given matrix A. It is 3 iota, 1 plus iota, 7, minus 1 plus iota, 0, minus 2 minus 7. So this implies that the given matrix A theta is equals to minus of A, which implies that the given matrix is skew Hermitian matrix. Skew Hermitian matrix. So you can write it very easily and check them. Okay, there is no issue in checking. So similarly, now we did some questions also here based on the Hermitian and the skew Hermitian matrix. Now for example, let me do, but before going to the examples, I would love to explain some other matrix also based on the skew Hermitian and Hermitian, like unitary matrix. Unitary matrix. So what about the unitary matrix? A complex square matrix, a simple definition, a complex square matrix capital A is said to be unitary matrix, is said to be unitary if A conjugate transpose, that is A theta into A is equals to identity, right? Or we can see, or we can write also A conjugate transpose into A is equals to identity, right? So taking the conjugate of both the side, if we take the conjugate of both the side, Okay, we will do it in the, now if A conjugate transpose into A equals to identity, if we take the conjugate of both the side, so we get a conjugate, the conjugate of a conjugate matrix is again the same matrix A transpose into A conjugate is equals to the conjugate of the identity matrix is again identity. So this implies that A transpose into A conjugate is equals to identity. In case of unitary matrix, you can see also this definition. Okay. So in case of real matrix, if we have the real matrix, it is the complex matrix. Okay. So in case of real matrix, in case of real matrix, it is the complex matrix. So what we do in case of real matrix, so simply A conjugate will be the simply equals to A, right? And it will be A into A transpose equals to identity. So it is what? Which we have discussed just now. Okay. Then it is said to be the orthogonal matrix. Okay. If A is real, then A is orthogonal matrix. Okay. Then A is orthogonal matrix. Hence the orthogonal matrix is unitary. Hence every orthogonal matrix is unitary. Hence every orthogonal matrix is unitary. We have discussed in the previous lecture the orthogonal matrices. So in case of the real matrix, all the entries will be real, so A conjugate will be equals to A. So here we will write the A value of A conjugate equals to A. So we get A into A transpose or A transpose into A equals to identity, which is an orthogonal matrix. So this implies that every orthogonal matrix is the unitary matrix. Okay guys, so here we have some properties of the unitary matrix also. Properties of unitary matrix. What about the property? The determinant of the unitary matrix is of modulus unity. The determinant of a unitary matrix is of modulus, is of unit modulus or modulus unity, right? Now we know that for the proof, consider A is the Hermitian matrix. Consider A is the unitary matrix. Sorry, no, we are not talking about here the Hermitian. Consider A is a unitary matrix. So this implies that if A is the unitary matrix, then A conjugate transpose into A will be equals to identity. Now take the determinant of both the sides. A conjugate into A is equals to identity. So by this you can find here A conjugate transpose into A is equals to 1. Okay. One more thing to be noted here. Take inverse of both these sides. Okay, we have studied, the determinant of the matrix and its inverse are equivalent, right? So here you can say A inverse theta into A inverse is equals to inverse of the identity is again identity, that is 1. Okay, and this implies that what? This implies that and the determinant of this transpose, okay, conjugate transpose, so it will be A and into A. Actually, taking the determinant of both the side, we don't need to write this. Okay, we can say the conjugate A theta means the conjugate transpose, right, equals to identity, and we know that the determinant of the matrix A and its transpose both are equal, so we can write here the determinant of conjugate of A into A is equals to identity, and we are also very well aware the determinant of the matrix A and its conjugate are equal, so we can write the determinant of A square is equals to identity. So from here, sorry, 1, from here 1. Okay, so this implies that the determinant of the matrix is, hence it is unit. Okay, so determinant of the matrix A is unit, right? So now we go to the next property. In case of the unitary matrix, the product of two unitary matrices of the same order is also unitary. Second property, the product of two unitary matrices the product of two unitary matrices of the same order is unitary, right? Now proof. Let A comma B be to unitary matrix. Be to unitary matrix. Then A into A conjugate transpose is equals to identity, and B into B conjugate transform is equal to identity. Now we need to show that the product of these two unitary matrix is again unitary matrix. That is, we need to prove A into B and A into B transpose conjugate is equals to identity. So to prove this, here we apply the simple steps. A into B. Now we apply the reverse law, that is B transpose conjugate into B A transpose conjugate. Okay, by the reverse law. Okay, now here we can apply the associativity, A into B conjugate transpose into A conjugate transpose. यहाँ पे हम associativity अप्लाई कर रहे हैं, associativity. Okay, then we are applying here the properties of the Hermitian matrix, that is I into A theta. Since B is Hermitian matrix, unitary matrix. B is unitary matrix. Okay, similarly you can write here A into because identity can be observed by any of the matrix. So into a theta is equals to identity because A is the Hermitian matrix, A is the unitary matrix, sorry, A is the unitary matrix. So guys, these properties are quite easy to prove. अगर ये आपसे एग्जाम में पूछ भी ली जाए ना तो ये बहुत मुश्किल नहीं है. एंड द इनवर्स ऑफ ए यूनिटरी मैट्रिक्स इज अगेन द यूनिटरी मैट्रिक्स. ओके, एक छोटी सी प्रॉपर्टी आप ये भी देख लें. द इनवर्स ऑफ ए यूनिटरी मैट्रिक्स, और इनको पढ़ना है ना, छोड़ना नहीं. द इनवर्स ऑफ ए यूनिटरी मैट्रिक्स is a unitary matrix, is a unitary. Right? So to prove the inverse of the unitary matrix, so we need to prove the A inverse theta into A inverse is equals to identity. We need to prove it. Okay, ये हमें prove करना है. Okay, so to prove this हम क्या करेंगे, लेट कैपिटल ए बी द यूनिटरी मैट्रिक्स. लेट कैपिटल ए बी अ यूनिटरी मैट्रिक्स. देन ए कंजुगेट ट्रांसपोज इनटू ए इज इक्वल्स टू आइडेंटिटी. राइट, नाउ टेक द इनवर्स ऑफ बोथ द साइड. टेक द इनवर्स ऑफ बोथ द साइड, दैट इज A conjugate transpose into A minus 1 and I minus 1. If two matrices are equal, then their inverse will also be equal. Okay, now we can apply. Now here by taking the inverse, it will follow the reverse law, the reverse property of the inverse, that is A inverse into A theta inverse equals to identity. So A theta inverse, we can write A inverse theta equals to identity, because the inverse of the identity is again identity, right? So here we can write A inverse into A inverse theta equals to identity. This implies that A inverse is the unitary matrix. So guys, here we have discussed complex matrix, okay, and complex conjugate matrix, conjugate transpose of a matrix, transpose conjugate of a matrix, Hermitian matrix, skew Hermitian matrix, unitary matrix and their properties. So now to deal with this theory, we will discuss some questions based on this theory. Now question number 1 here is, if capital A equals to 2 plus iota and minus 5 and 3, then 1, then minus 1 plus 3 iota and 4 minus 2 iota. Now verify that A theta into A is Hermitian matrix. Now verify that A theta into A is Hermitian matrix. Is Hermitian matrix. Now the solution, we have the given matrix A is equals to, although we can write its the given matrix A equals to 2 plus iota 3 minus 1 plus 3 iota and minus 5 1 4 minus 2 iota. Then we can write it here, its transpose, that A transpose, conjugate transpose, we need to prove it Hermitian. So we need to write its conjugate and then transpose. So first we write its conjugate. So conjugate is 2 minus iota 3 minus 1 minus 3 iota and minus 5, then 1 4 and plus 2 iota. Right, now we take its transpose. At is equals to, it will be 2 plus iota and minus 5 and 3, and it is 1, right, and it is -1 plus 3 iota and 4 minus 2 iota. So guys, it is a theta conjugate transpose of the given matrix, right? So here we can check a into a theta. Okay, so verify a into a theta is Hermitian matrix. We need to verify it. A into a theta is Hermitian matrix. So we will multiply by here a into a theta, and then we will get the resultant matrix there. Now, first of all, we need to find the a into a theta. A into a theta. So what about the matrix A? Matrix A is 2 plus iota, then 3, then -1 plus 3 iota. भाई साहब बहुत छोटा छोटा सा काम करना है, कुछ भी बड़ा काम नहीं कर रहे हैं. माइंड को बिल्कुल भी स्ट्रेस मत देना, ठीक है. और ये छोटे छोटे से स्टेप्स आपने फॉलो करने हैं. आपको क्या प्रूव करना है फिर से मैं आपको बता दे रहा हूँ. कभी कभी तस्वीर क्लियर नहीं हो पाती दिमाग में कि हम करना क्या चाह रहे हैं, ठीक है भाई. हमने प्रूव करना है a इंटू ए इज़ द हर्मिशियन मैट्रिक्स, यानी कि हमें प्रूव करना है कि a इंटू ए हर्मिशियन है. तो हर्मिशियन प्रूव करने के लिए हमें क्या करना होगा कि इसका जो ट्रांसपोज कंजुगेट है ना, वो a थीटा इंटू ए के ही बराबर है ना. ये हमें प्रूव करना है, क्योंकि फॉर द हर्मिशियन मैट्रिक्स हमारे पास होता क्या है, a थीटा इज इक्वल्स टू a, राइट. फॉर द स्क्यू हर्मिशियन मैट्रिक्स a थीटा इज इक्वल्स टू माइनस ऑफ a, ठीक. सो हमें a थीटा इंटू ए को हर्मिशियन प्रूव करना है. तो हमने a थीटा और a तो हमने निकाल लिया. यहाँ पे एक्चुअली हम निकालेंगे a थीटा इंटू ए. हमें ना ध्यान रखना है, क्योंकि हमें a थीटा a को हर्मिशियन प्रूव करना है, तो हम a इंटू ए थीटा की बजाय a थीटा इंटू ए निकालें, ठीक है. इसका क्योंकि मैट्रिक्स का a इंटू बी ज़रूर नहीं होता b और b इंटू ए के बराबर हो, है ना. तो इसको पहले लिखिए आप, -1 प्लस 3 आयोटा, -5 1, देन 4 माइनस 2 आयोटा, and then multiply by 2 plus iota, 3 -1 plus 3 iota, then -5, then 1, then 4 minus 2 iota, and you can write the resultant matrix here. भाई इन दोनों को मल्टीप्लाई करना, फर्स्ट रो फर्स्ट कॉलम, फर्स्ट रो सेकंड कॉलम, है ना. और ये मल्टीप्लिकेशन आपको यहाँ पे करना है. तो फाइनली मैं इसका रिजल्टेंट मैट्रिक्स लिख दे रहा हूँ. इट विल बी 30 and 36 minus, let me write it. Okay, it will be 36 plus 8 iota. ये आपका काम है, आप इसको करना कैलकुलेशन, है ना. and -19 plus 17 iota, right. 6 plus 8 iota, 10, and -5 plus 5 iota, and it is again 30, and 6 plus 3 iota, or 6 plus 8 iota, 6 plus let me complete it. 36 plus 8 iota, and -19 minus 17 iota, -19 and -17 iota, then 6 minus 8 iota, 10, and -5 minus iota, it is -5 and minus, I'm writing here -5 and -5 iota, right. -19 plus 7 iota, -5 plus 5 iota, and then 30. Okay, so it is the a theta into a. Now guys, what we need to require here, consider it b. We need to prove b theta into b is equals to what? We need to prove b theta is equals to b. to prove it Hermitian. So we have B. Now we need to prove B theta. B theta means B conjugate transpose. B theta means B conjugate transpose. So what about B theta? So whatever we have deduced the final matrix, first we take the transpose it, then we will take the conjugate of it. So what about the conjugate transpose? I am writing it here. It will be again 30. भाई चेक कर लेना आप अपने से, है ना. 36 minus 8 iota and minus 19 plus 17 iota. Okay, then 6 plus 8 iota, right, and 10 minus 5 minus iota, minus 5 minus 5 iota, minus 19 minus 17 iota, and here we have minus 5 minus 5 iota and 30, which is equals to B. So it is the Hermitian matrix, and there are very simple manipulations. Okay, so guys, here I'm going to discuss the one another questions also based on the Hermitian or Skew Hermitian. I'm writing here a question, and the question is if capital A is equals to minus 1 2 minus iota 5 plus 3 iota 2 plus iota 7 minus 5 iota 5 minus. We prove for this given matrix as a Hermitian and iota into A as a skew Hermitian. Now come to the solution. So for the Hermitian matrix, we should know A transpose conjugate is equals to A, and for skew Hermitian, A transpose conjugate is equals to minus of A. We need to prove this. Okay, so come on, we need to solve it. Now to check the Hermitian matrix, first of all we write A transpose conjugate. So for the given matrix A, first we write the conjugate. So minus 1 will be minus 1, 2 minus iota, and 5 plus 3 iota, then 2 plus iota, then 7 and minus 5 iota, then 5 minus 3 iota, then 5 iota, and then 2, which is the conjugate of the given matrix. Now find its transpose. Just convert the rows into the column and column into the rows. So minus 1, 2 minus iota, 5 plus iota first row into the column, then second row 2 plus iota, 7 minus 5 iota, then third row 5 minus 3 iota, then 5 minus 3 iota, then 5 iota, and then 2. Okay, so now we check, is it equals to A? Obviously minus 1 2 plus iota. So if we see, then it is equals to A. So we can say A theta is equals to A, and this implies that A is the Hermitian matrix. A is the Hermitian matrix. ये छोटू छोटू सा काम करना है अपने, है ना। कोई भी बड़ा काम यहाँ पे नहीं कर रहे हैं, बहुत छोटे छोटा सा काम. For the skew Hermitian matrix, first of all, we write iota into A. We multiply by iota. Okay. So what is the matrix A? It is the matrix A. It is the matrix A, right? So here we multiply by iota. So it is minus iota and 2 iota, and iota square will be minus 1, right? And 5 iota, and iota square will be minus 1, that is plus 3, right? And 2 minus iota means 2 iota. Iota is iota square, that is minus 1, that is plus 1, right? And it is 7 iota, right? And 5 iota square, that is minus 5 iota. If you multiply by iota in this number, then it will be 5 iota square, and iota square is minus 1. So next 5 iota and minus 3, or 5, right? It is 5 iota square is minus 1, so it is 5, then it is 2 iota. So it is, we need to prove it that it's a skew Hermitian matrix. So here we try to find out the iota A to the power theta, that is iota A conjugate transpose of this. So first of all we write its conjugate matrix. So it is iota, then 2 iota plus 1, and then minus 2 iota and minus 1, because in the conjugate iota will be minus iota only. So it is minus 5 iota, then plus 3, and 2 iota, then plus 1, and it is minus 7 iota, and it is minus 5, and it is minus 5 iota, minus 3, and it is 5, and it is minus 2 iota, right? Transpose. So as a resultant, the matrix will be equals to, now we transpose it. So it is iota, first two will be converted into the column, okay, iota and minus 2 iota, minus 2 iota minus 1, right? Minus 2 iota minus 1, and then it is minus 5 iota and then plus 3, and second row, the second column, minus 2 iota then plus 1, and minus 7 iota and minus 5, right? So it is minus 5 iota minus 3 and 5 and minus 2 iota. So guys, it is the given matrix. Here we need to check iota A conjugate transpose is equals to, if I take the minus common from it, so here it will be minus iota, 2 iota minus 1, and 5 iota plus 3, right? And it will be 2 iota plus 1, 7 iota and minus 5, right? And it will be 5 iota minus 3, then 5, and then 2 iota, okay, and which is equals to nothing but the matrix A, right? It is the matrix A, okay. So by this property, not only the matrix A, but although iota A, negative iota A, so it is skew Hermitian. This implies that iota A is a skew Hermitian matrix, is a skew Hermitian matrix. So it is very easy to verify, okay, for the given matrix as a Hermitian and skew Hermitian matrix. Now we discuss the next part, that is the one question based on the unitary matrix, right? Unitary matrix. And we have discussed in the unitary matrix. So I am writing here the direct question for the unitary matrix. Prove that, a small question. Prove that 1 by 2, 1 plus iota, 1 plus iota, and minus 1 plus iota, minus 1 plus iota, and 1 plus iota. Here again we have 1 plus iota and 1 minus iota, 1 minus iota. So prove that is a unitary matrix. We need to prove is a unitary matrix. So to prove that it is a unitary matrix, we need to prove for the unitary matrix, we need to prove A theta into A is equals to identity. If A is the unitary matrix, then we should satisfy it. Okay. So here the given matrix A is equals to 1 by 2, 1 plus iota, minus 1 plus iota, 1 plus iota, 1 minus iota. So first of all we write its transpose conjugate, okay, or conjugate transpose, that is A theta, right, that is equals to 1 by 2, 1 minus iota, minus 1 minus iota, 1 minus iota, 1 plus iota, right. Now it is the conjugate of this given matrix. Okay, now we transpose it, that is 1 by 2, convert the row, first row into the column, that is minus 1 minus iota, and 1 minus iota, and 1 plus iota. Okay, now it is the A theta, and now we multiply A theta into A. Okay, so for this case, here we have A theta, that is 1 by 2, 1 minus iota, 1 minus iota, and minus 1 minus iota, 1 plus iota. It is what? A theta, right? Into 1 by 2. What about the matrix A? Matrix A is 1 plus iota, minus 1 plus iota, 1 plus iota, and 1 minus iota. So here we will multiply this matrix, right? So first row multiply by first column. So 1 minus iota into 1 plus iota, and plus 1 minus iota and 1 plus iota. It is the first row and second column. So it is 1 minus iota and minus 1 plus iota, right? And then plus 1 minus iota and 1 minus iota, right? Similarly, the second row and the first column, that is minus 1 plus iota and 1 plus iota. So after multiply these two matrices, we get 1 by 4 equals to this, right? First row, first column, first row, second column, first row, second row, first column, second row, and second column. So we have these calculations. Okay, after solving this, we get this. So here finally we are getting 1 by 4. So it is 1 minus iota square is plus 1, so it is 4, and it is cancelled out by this, that is, it is 0. Similarly, it is cancelled out by this, it is again 0, and here we have again 4. So 4 we can take outside. So 4 divided 4 equals to 1, sorry, 1 0 0 1. So it is identity. So this implies that A theta into A is equals to identity, and which shows that A is the unitary matrix. A is the unitary matrix. So guys, we have studied unitary matrix, Hermitian matrix, Skew Hermitian matrix. Okay, So in the next lecture, we will deal a very important topic of the matrices and last topic of the unit of this of the first unit, that is eigenvalues and eigenvector, characteristic equations, characteristics roots. Okay, so be ready for the next video, and finally I request everyone to subscribe, comment, and like the channel, and share the video among your friends to so that they can benefit it. Okay, so see you in the next class. Thank you very much.